So today we will study about deterioration of concrete structure due to physical cause. So we will know what are all the physical causes responsible for deterioration of concrete structure. So let's start. Okay. The major factor responsible for this type of deterioration is the volumetric changes in the building material. So we know that structures are made with building materials. So one of the major factor which is responsible for deterioration, the physical cause, is volumetric change. Means there is a change in the volume of the building material. Understood? Okay. These volumetric changes, which are due to environmental changes or in some cases due to aging of materials, cause strains that leads to structural movement. So what is happening here? Why these volumetric changes are there in building material? They are because of environmental changes or in some cases due to aging of the material. So first is environmental factor, second is your aging of the material. So these two are major responsible for the deterioration of concrete structure, the physical cause, environmental and aging. Okay. Which causes strains that led to structural movement. And if there is structural movement in any structure, then concrete or the structure is bound to be weak. So it's general a basic principle of civil engineering. Just remember the tension forces which are responsible for this. Tensile forces. If these strains or movement are constrained in some way, then the stresses built up due to these constrained movement cause damages in the structure. If these strains or movement are constrained in some way, suppose if the building materials due to volumetric change due to volumetric change, if they are not able to move or they are constrained in some way, they are packed by the particle, their particle density is very high, then it becomes difficult for the particles to have a movement. And if they are not able to move, then stresses build up due to constrained movement caused, and these constrained movement cause damages in the structure. So you have to understand like this. Suppose this is a concrete structure, there are particles in concrete structure and they want to move, but they are not able to move because of some bound between the particles. That is, it may be cement hydration particle or whatever. It could be ITZ, interfacial transition zone also. So they are not able to move. So if they are not able to move, then definitely they are going to cause a harm to the structure, because tensile forces will develop in the structure, and concrete structure is weak in tension. So we have to understand this topic in this way. What is the basic reason for this? Okay, so let's move forward. If these strains or movement are constrained in some way, then stresses build up due to these constrained movement cause damages in the structure. The most common environmental condition that cause volumetric changes are changes in temperature and moisture. So ये जो environmental changes हो रहे हैं वो किसकी वजह से हो रहा है? Temperature and moisture. So just remember, in civil engineering, temperature and moisture is considered to be a physical factor, and it is physical cause of deterioration of concrete structure. So all common building material are expand and contract with changes in the temperature. We know that building materials expand it gets expand from this to this, and gets contract also, this to this. So how that happens? That happens because of the changes in the temperature. If there is cold, if there is warm temperature, then definitely it would have some effect on concrete structure. So the amount of expansion or contraction depend upon the coefficient of thermal expansion. So the amount of expansion, कितना expansion होगा और कितना contraction होगा, it depends on the coefficient of thermal expansion of the material under some heating condition or similar materials under different thermal condition. So I hope you would have understood this. So the main thing which we need to understand, that the major factor responsible for deterioration of concrete structure is volumetric change. How this volumetric changes happen? Due to environmental changes or due to aging of materials. What it causes? It causes structural movement, and if these structural movement are restrained in some way, then the stresses build up and they causes damage to the structures. And the most common environmental condition that cause volumetric changes are temperature and moisture. Okay, all common building materials expand and contract depending upon the condition or coefficient of thermal expansion, or under some others some heating condition or similar material under different thermal. Okay, we have seen what are the factors responsible for this volumetric changes. What is that? Temperature and moisture. So now we will look about temperature. So deterioration due to differential thermal exposure. So let's start. The temperature difference within a concrete structure results in differential volume change. So if there is temperature difference within a concrete structure, it will lead to differential volume change. There will be a volume change when there is a temperature difference. When the tensile strain due to differential volume change exceeds the tensile strain capacity of concrete, it cracks. So we need to understand this point. This is very important point. When the tensile strain due to differential volume change exceeds the tensile strain capacity of concrete. So there must be a tensile strain capacity of concrete. This is a concrete. It must be having some capacity, tensile strain capacity. So what this point is telling here, that when the tensile strain due to differential volume change, because of differential volume change, when tensile strain exceeds this capacity, it cracks. Please go through this point. This is very important point. The uneven thermal expansion associated with thermal effects generated during the hydration of cement affects the mass concrete structures like dams, large columns, piers, footing, whereas the temperature differential due to changes in the ambient temperature can affect any structure. Okay. The uneven thermal expansion. The uneven thermal expansion means when the thermal expansion is not even, it is fluctuating, associated with the thermal effects. This uneven thermal expansion, when associates with the thermal effect generated during the hydration of cement. So when there is hydration of cement, a lot of heat is generated due to the water cement reaction. So this uneven thermal expansion associated with thermal effects generated during the hydration of cement affect the mass concrete structures like dam, large column, piers, footing. It affects these things. Whereas the temperature difference due to changes in the ambient temperature can affect any structure. Whereas the temperature difference due to ambient temperature means you can say environmental temperature can cause effect to any structure. The liberation of heat of hydration of cement raises the temperature of concrete. As you know, that there is a water cement reaction when cement is mixed with water, so we generally call it as heat of hydration. So when this happens, the temperature of the cement raises, or concrete raises, so that concrete is usually slightly warmer than its surroundings. So if you ever go to site, if you encounter a pier which has been cast in night, and if you touch the surface of the concrete in the morning, you will find it is very much hot. So why it is hot? Because reaction is continuously going on. The reaction is continuously going on, and it is liberating a huge amount of heat because of the reaction between water and cement. So that is what it is telling here. The liberation of heat of hydration of cement raises the temperature of concrete, so that the concrete is slightly warmer than its surrounding when it hardens. Okay. For example, a concrete dam's surface cools down faster than the interior. It is giving an example that a concrete dam surface, the surface of the concrete dam concrete, cools down faster than the interior. जो सरफेस है डैम का, वो कूल करता है जल्दी इंटीरियर से. When the interiors cool down, it tends to pull away from the hardened exterior surface, resulting into tensile strength, and eventually it cracks in different layers. It is also one of the important points. When the interior cools down, it tends to pull away from the hardened exterior surface. See, if there is a wall and here the temperature is different and here the temperature is different, so interior it is cold, outside it is warmer, then what it will do, it will produce tensile stresses, and those tensile stress will lead to cracks in different layer. So आपने देखा होगा कभी भी कोई वॉल भी आप करते हो तो आपको क्रैक दिखाई देंगे, अगर आप कभी देखो तो. Wall means concrete structure, sorry, not wall, concrete structures. Okay, so let's move forward. Lowering of temperature may cause cracking of the exposed element, while an increase in the temperature may cause cracking in the protected portion of the structure. So if we lower the temperature, it may cause cracking in the exposed element, while if we increase the temperature, it may cause cracking in the protected portion of the structure. The contraction and expansion that result due to seasonal temperature fluctuation. So there is contraction, there is expansion due to the seasonal temperature fluctuation can cause pre-existing cracks to open and close. So if there is contraction and if there is expansion, then what it will do, it will lead to different types of cracks. The cracks will open sometimes and cracks will close sometimes, depending upon the expansion and contraction. Suppose the concrete expanded this much in suppose summer season, and then it get contracted again like this in winter season. So this is what it is telling here. Temperature gradient cause deflection and rotation in the structure member. Temperature difference can cause deflection also, rotation in the structure member also. But if a normal person will study this, they will think that how it is possible, we can't see it. We are not able to see any movement in the structure, but these movements are very, very slow, progressive. Means it takes years to show, because if you, for example, even if you make a bridge, you see that that bridge is going for more than 100 years. So how you will be able to see that? It's impossible. Okay, so let's move forward. Okay, this is illustrated in figure. The temperature on the surface of the bridge deck is higher in comparison to the surface on its soffit. The temperature gradient is known as diurnal solar heating, causes the top surface to expand more than the bottom surface. Okay, so we will see. So there is a figure, we will see that. So what that figure is telling, the temperature on the surface of the bridge deck, the temperature on bridge deck is higher. The temperature gradient is known as diurnal solar heating, due to solar heating, which causes the top surface to expand more than the bottom. So if there is a bridge, there is continuous heat here. So what is happening, due to the exposed heat, it will expand more as compared to the bottom, because in bottom the heat is not directly coming. So that is what this is telling. So we will see. A member of 18 meter as shown in the figure, in case of normal diurnal solar heating, moves upward by 19 mm in mid-span, causes the end to rotate and stresses the bearing pads on the beam. Okay, we will see. So this is the bridge deck. This is the bridge deck. This is bridge deck. What is happening here? Due to continuous sunlight, this layer is expanding more as compared to this layer. So what is happening, we will see here. So if this top layer expanded, then it will move in upward direction like this, and due to this it will produce stresses here, it will produce stresses here, it will produce stresses at the bearings. So this is what I am telling, and you can see the temperature difference. Here it is 60 degree, here it is 30 degree. So always remember, whenever you are going to a bridge, you would see some type of joints in between the bridges. That is what we call as expansion joint. It is also provided for the expansion and contraction due to thermal changes, temperature changes. So it is one of the best example through figure we can understand that what generally happens in general condition. Cracking of bridge deck due to uneven thermal heating. So these types of cracks in the bridge is very common, but it is not very much prevalent. It is very slowly progressive, and it generally happens more in the summer season, in the peak summer season in India. So finally, I would like to tell you that there is a solution for this thermal expansion, and as I have already told you that we use expansion joint. Expansion joint. We use expansion joint. And here also you can see that, but non-uniformity of thermal expansion of first sight is a material problem, but actually it is better to be considered as structural problem. If there is cracking, then it must be accessed as structural problem. Allowing for movements by using properly designed contraction joint and correct detailing, so we can get rid of these. So it is telling the same thing, we can use expansion joint. So With this, we have come to the end of this topic, and I have already said there are two major factors responsible for deterioration of concrete structures. One is temperature, and the other one is moisture. These two are the major physical causes. We have studied about temperature effects, and now we will deal with moisture effects. So we will deal with that in the second part. So thank you very much.